Hello everyone, this is Bir Bohara. In this short video, I'm discussing about Maxwell's equations. These equations are very important and very fundamental equations that describes fundamentals of electromagnetism. So let's dive into Maxwell's equation. The first equation here is Gauss law for electric field. Here is the electric field E, and it states that the flux of electric field through a closed surface, which is represented by integration of electric field with respect to area, integration of E dot dA equals to the total charge enclosed by the surface, that is represented by Q enclosed, divided by electric constant. So basically, Gauss's law for electric field provides you the relationship between electric flux passing through a closed surface and the total charge enclosed by that surface that we call Gaussian surface, which is very important relationship because based on the total charge enclosed inside the surface that you are trying to find the electric field, you can find out the relationship between the total charge enclosed and the electric field on the surface that we call Gaussian surface. So this is the first and most important Maxwell's equation. The second equation tells you about the Gauss's law for magnetic field, which is V. This tells you the relationship between the flux of magnetic field through any closed surface, which is actually equal to zero. That is talking about the magnetic poles, because there is no existence of magnetic monopole. We don't have any number here on the right hand side of Gauss's law for magnetic field. This equation basically tells you about the absence of magnetic monopole. There is no existence of magnetic monopole. If you break down a magnet into its pieces, you cannot find a single pole like North Pole or South Pole. There will always be creation of second pole once you divide a magnet, break a magnet into two pieces or more than two pieces. Okay, so this is a Gauss law for magnetic field. The third Maxwell's law is the Faraday's law for stationary integration path. Right here, we are integrating with respect to the line, which that we call line integral, and the line integral of electric field around the path, which is E dot dl. This closed circle, a small tiny circle right here, represents a closed path. So line integral of electric field around a path will be equal to negative of time rate of change of magnetic flux. Pi b right here is the magnetic flux, and as a whole, this term is the time rate of change of magnetic flux through the path. This gives you the relationship between electric field and magnetic field. If there is changing magnetic field, electric field will be generated. This is very important realization. And the last equation, which is much more important than any other equation, because in this equation, which is called Ampere's law for a stationary integral path, there is a current that we call displacement current, and Maxwell realized the first time about this current. And this is very important because when there is a current passing through one plate of a capacitor to the another capacitor plate, there is no conduction current passing between those capacitor plates, right? If we are talking about the condenser measuring conduction current between the plates, you can't find anything, but there is a kind of current that we can call it displacement current, and it is given by right here. You can see epsilon naught, which is electric current, d pi e by dt. It is in the form of electric field, or we can say in the form of time rate of change of electric flux through that path. Okay, so this is called displacement current. So as a whole, Ampere's law gives you the relationship between the line integral of magnetic field around the path, which is the magnetic field, will be equal to this conduction current through the path plus displacement current right here. Mu naught here is the magnetic constant. And then IC is the conduction current through the path. And this second term right here, electric constant multiplied with the time rate of change of electric flux through the path, which is as a whole, the product of the electric constant and the time rate of change of electric flux through the path is said to be a displacement current through the path. So this is the most important realization finding of Maxwell. He put all of these equations together and called Maxwell's equations. And these equations are crucial, very important for understanding fundamentals of the physics. So this will be very, very helpful if you understand all of these equations, their significance. You will understand everything basics about fundamentals about electricity and magnetism.